Hi, everyone, and welcome to Module 2. This is the lecture on the Linux command line introduction. So let's have a pop quiz, so to speak. So what is the command line? The command line for a computer has sometimes multiple names. So in this case, we'll be talking about the Linux command line, but it can also be called a terminal. In Windows, it's called a command line. It's that command little black box that you open up on a Windows box to type in various commands, sometimes to find folders or programs and copy things around. It has its roots back all the way to the 1960s and all the way up to the 70s and 80s and 90s and 2000s and today. And so it's used still to this day, and we talk about it from a concept of software development. So I'll try to answer the why and when of command line. So what are Linux commands? Linux commands are programs built into the operating system. These are programs like touch or date or who am I. These are all commands that come pre-installed on a Linux machine, and if you go to your command line, type in who am I, it will output who is the person that is logged in. It could be whatever your username is, administrator or John Doe. It was actually created in around 1991 by a guy named Linus Torvald. It has roots in Unix land, which you had to actually pay for Unix, but Linus wanted to have an operating system that was available and free and open and had a community that developed around it, and Linux was born. And there's multiple iterations of Linux now. There's concepts like Red Hat, CentOS, Fedora, Ubuntu. There's FreeBSD that powers is kind of underneath the hood for a Mac computer. So that's some of the origin of Linux there. So in general, Linux commands help navigate a computer, or they can sometimes manipulate data, and they can also help share information between computing systems. You'll find that they're really essential for handling large data sets and simplifying complex tasks. And we'll get into more of that in a few more slides. So why do we use Linux commands still? So Linux commands help us create repeatable complex processes. You can write a Linux or a script, a shell script, and put a series of Linux commands in there, and you can call that script whenever you need to split a file up into multiple. So say you have a 10 gig file, it's absolutely huge, and you're trying to send it to someone else, or a 100 gig file to make it even large in today's terms. You need to split this file up into 5 chunks or 4 chunks or 16 chunks of data. There's a command called split, and you can split that file up and just send the smaller files. And then you can do that on a repeatable basis. Basically, you can schedule it, and it can just automatically run as some process is happening. Linux commands help us share data in a safe and repeatable way. That kind of gets back to the repeating complex processes. But the shared data aspect is that you can create a bash shell script that schedules a copy of a file from one server to another to share data out. Linux commands can also help us manipulate data in different formats. So, when you're dealing with smaller data sets, you can use things like Excel or a spreadsheet type application. At some point, you're going to reach a maximum of what Excel or a spreadsheet software can do, and so there might be times when you need to manipulate data before you use a GUI, interface like what Excel and what a spreadsheet software will offer. So you might have to pare a large file down. So say that you get 150 gig or 200 gig file is huge. It's got 1,000,000 rows and 10,000 columns, and it's just a really huge data set. But I'm only interested in the first 10 rows or rows 1 through 5, and then 16 and 20. Well, there's Linux commands that can help you cut those columns out, and then you can go more easily manipulate and run formulas on them and do pivot tables in a spreadsheet software. So Linux can help with that. Linux commands help us navigate and maintain files. At their base functionality, especially back before there was things like File Explorer in Windows or Finder in Mac, you could create directories, create files, delete files, move files, copy files. All these concepts are in Linux, and they go back a long ways. A couple of commands here are exampled. rsync is a favorite. It's a more recent program, like late 90s, mid 90s. But you use it to transfer data over an encrypted channel, every time data changes. So say that you have a 10 gig file on a server in Australia. You do an rsync command to start synchronizing this 10 gig file with a computer over in Europe. And what rsync does is it acts a lot like Dropbox in a way. It starts synchronizing that file to another computer. And then if there's any change, rsync is smart enough to send the small bits of incremental change that happen. So if you only change 5 megabytes of this 1 gig file or 10 gig file, it synchronizes just the change. So rsync is really cool like that. grep is another common command. You do searches for inside of a data set or a file for a particular term, and show the location of where that word or the string of words is in the file. So there's this, it's almost like a verb now, go Google that term. Well, the first iteration of this was go grep that term. Go search in this file for the term, metabolomics or, car parts, whatever the file of the data might be, you can grep for information inside that file using grep. Cut is another command where you can clean or reduce data for processing into another pipeline. Linux has this idea that you can literally pipe. You could run grep and grep out the lines that like lines 1 through 10 of a file, and then you could cut the last 10 characters off of every line in that file to get down to a 10 row, 80 character wide file. So cut can cut certain parts of a file out. It can cut individual lines. It can cut the length of a line. That's the very common command. So the question is, when should you use Linux commands? And so I've been kind of going over that, but when you have a manual process that becomes difficult to do by hand, kind of going back to that huge Excel file or spreadsheet file, again, 1,000,000 rows and 10,000 columns or 1,000 columns and 10,000 rows. That's a pretty large file, and so that's kind of a manual process where you're trying to manually, manipulate that data, and so it gets just too big for a graphical interface. And so you can go back to these commands that has existed for decades and start manipulating that information and viewing it and creating summaries of these information, and then go back to some other program that can help you handle the data. So you also want to do it when data needs to be moved from one point to another. So one point to another could be from one directory in your computer to another directory. Another idea, so say that on your own computer, why wouldn't you just go to File Explorer? We'll say that you have multiple tens of thousands of files spread across multiple directories, and you want to move them into one directory. You can run a command for copy. CP is the program in Linux, and copy the files from multiple directories into a single directory. And then also you can copy files from one computer to another, across the world, or across the United States, or in the same city kind of thing. You should also use Linux commands each time a new feature or enhancement is created for one of our project's software. And then you also, when a system doesn't have a GUI, you can find this commonly, the GUI interface is, what we're used to in Windows or in Mac, where we have a Finder, we have apps, we have things we can click on to launch programs. We have a start button. We can launch programs and, function a computer. But a lot of times servers and systems do not have a graphical user interface, a GUI, where you can click on things and launch programs. It's just a command line terminal on a server, and you have to reboot the server or copy files. And so you definitely have to use Linux commands when you don't have a GUI installed. So how do we use Linux commands? I've been giving some examples, but we'll go into some more. So Linux commands themselves are split into kind of categories, essentially, right? You have file commands, which are those programs listed there. LS, list, contents of a directory. PWD, which is present working directory. That tells you, what folder am I in on my hard drive. Cat, where you can cat a file, meaning that you type in cat space and then the file name, and it displays the contents of that file on your screen. You can do less, where you less a file. Again, cat might show you the entire file. Well, I'd only want to see the first 10 lines, the first 50 lines. Well, less is a program like that can do that. A tail is another program for file commands, and it tails a file, meaning it shows you the tail end of a file. And CD is change directory. It's allows you to change from one directory to another. If you find you're in your home drive and you want to go to the downloads folder or your desktop, you can change directory into that folder. Another category is like system commands, things like date. If you go to your command line, type in date, it tells you what the computer's date time is. Who am I talked about a second ago. It tells you who's logged into the computer, and then there's a host name that tells you the name of your computer. There's file handling commands like copy, CP. There's remove there, RM, for removing a file or multiple files. There's MV for remove. You also use MV for renaming a file, actually. And then there's mkdir, which is make directory. There's also data manipulation commands. Programs like awk is extremely, extremely powerful. That example I gave you earlier, where you're trying to have it a spreadsheet, a CSV file, and it has 10,000 columns, but you only want the first 5, and then columns 16 and 20. Awk is great for stuff like that. Cut is another great command. Sed is extremely powerful. And then there's vim, and vim is one of a multitude of text editors. Instead of having a Microsoft Word or WordPerfect going back a ways, or Google Docs, there was Vim. It's one of the first programs that someone created to create a document on their computer. You start Vim, you start a new file, you type in text, and you save it. And then there's network commands, things that are used to get information from the internet, like wget. There's rsync we talked about a second ago for synchronizing computers across the network. There's SCP for secure copy for copying programs. There's SSH to where you can connect to another server and run commands on that server. And then there's curl, which is similar to wget, where you're curling, not the sport, but curling information from a location. So those are the different categories. File commands, I talked a bit about a second ago, but these commands help us understand the structure and format of the data so we can manipulate and transform it into something usable, or something else, I should say. It's used for viewing files in various ways. So system commands, again, I talked about these commands a moment ago. There's a couple additions here. df command. df is it's trying to describe your file system, and You can use it to look at how much file space you have on your system's hard drive. There's also top, which it doesn't really have a cool name for something, what it actually denotes, but top is a program that you run that tells you how many programs are running on your computer and then how much CPU and memory they're occupying. Then there's commands like uptime that tells you how long your computer has been booted up. Yeah, and then PS is a program that you can use to, it's process services. So if you run top and see that, something is really occupying your RAM or your computer or memory, it's overloading, you can type in PS and kill that command, basically. So these commands help us assess the computer systems that we support in order to diagnose potential problems. The file handling commands I talked about a moment ago, these commands help us place data into the location needed for further processing, as well as delete data which we no longer need. Data manipulation commands I went over again initially, but these commands help us filter data into a structure such that we can transfer information from one system to another. These are a lot of the manipulating data, but also creating new files. Network commands, as I said, are commands that help us move or gather data from one source to another so that we can manipulate and import the information to various databases if necessary, or just simply move a file from one location to another. So Linux command line extras are, in addition to the programs that we've talked about, vim, awk, grep, cut, move, copy, there are other concepts about Linux commands that you should know. So these are things like pipes, greater than, and tabs. So the pipe or the bar command, it's usually above your enter key, and you have to, I think, type in shift to get to it. But the pipe command is used to create what can be visualized as a pipeline of commands. You can, you can cat a file and then pipe that into grep, and then grep for a search string that outputs something, and then you can pipe that into another program. So it's a temporary direct connection between two or more simple programs. There's a YouTube video found there at that address that can that talks even more about it. So as I've said before, there's a Linux philosophy that you should build programs that do one thing really well, and this allows us to do chain programs together that all of them do their individual functions well. So cat's really great about opening a file, grep's really great about searching a file, and then cutting is really good about cutting file lines down to whatever you want. So then there's this other concept in Linux commands called the greater than symbol. And so the greater than symbol, so by default when you type in a command, it displays on your screen. However, what if you want to save the output of that command to a file? Well, if you type in, what's a great example of this? So when you type in, when you grep for something in a file and say, give me all of the lines or instances where the word generator is in that file, you can type in grep, the file name, the search phrase, and then you can type in the greater than symbol at the end of that, and then type in a file name like, instances of generator.txt, and you can output that command to a file. It's also called standard out, this concept of greater than, and so again, you're outputting a file to the hard drive. And another idea is that you can also use two greater than symbols. So the idea is that if you use a single greater than symbol, it outputs the file, the content of a program, or the output from a program to a file. And if you run it again, it just overwrites that file and does it again. But if you run the command and you want to add to the file, instead of completely overwriting it, you're using two greater than symbols to output the file and just keep adding to the file. So there's this other idea of bash completion or tab completion. So tab completion is used to automatically fill in partially typed commands which save time and headache while trying to remember commands or file names. So say that I type in cat and I have a file name that's 250 characters long, but I know the first 10 characters or 5 characters. I can type in cat space, this is my, and just stop there and hit tab, and that will fill out the whole file name. This is my file for this example.txt, and it will automatically display or try to guess which file that you're after instead of having to type out these really long strings. So it's a time saver, essentially, bash or tab completion. So let's talk about Linux command line scenarios, where I try to give you some examples of how we're doing or using Linux. Scenario 1, so we're trying to pull 2 columns of data from a file. Again, I use this example a lot. So here in this situation, we have someone named Ruchi and someone named Mohan, and they're working on an Alzheimer's disease research project and receive a file that has 5 columns of data, and they only need 2 columns from the file. They will use the awk command to filter out the 2 columns needed from a file called data.csv. So the command looks something like that. So what they're doing is they're using the cat command to cat the file or open the file, data.csv, and then they use the pipe command to take the output of the cat command and run it into the awk program. And so at that point, awk has several options that you need to use here. So -f. So -f is like, what is the file delimiter? Like, when you use Excel and you import data, sometimes it asks you about, what's the delimiter for this? Is it comma delimited? Is it semicolon delimited? Is it tab delimited? And so in this case, we're telling awk, well, this CSV file, which, comma separated, so it's a comma. So the file separator is a comma. And what I want you to do is print only columns 1 and 3 out of this file. And then it's using the greater than symbol and then outputting the results of the 2-column extraction into a new data.csv. So again, this can be used a lot to pull out data or columns or rows out of a file even. So awk's really awesome like that. Yeah, so I jumped ahead there. So in this scenario, we have a copy of a file between 2 servers. Ruchi is working on a file that is ready to be copied to a server for production use. She will use SCPs to securely copy the file from her laptop to the server. Securely, the aspect of this word securely means is that literally the tunnel that you create when you're copying between 2 servers is encrypted, so you can't see the data that's being sent. So the command looks something like this. So SCP is the command, secure copy, space, and then what she's doing is she's trying to copy a file called file.cfg or file config. And the next after the space is that she's specifying her username and then at the remote server host that she's connecting to, and then the colon, and then where she's putting it on that server. So Ruchi has a home drive on this remote host.edu, and so she's going to copy file.config to this remote host.edu into her home drive, home/Ruchi. Yeah. So after she runs this command, it will prompt her for her password for her to log in and transfer the file. Final scenario 3. Copy data from a server using an API. API is stands for Application Program Interface, and it is a tool that websites or a service that websites create or program to allow other computing systems to talk to other computing systems, or other applications talk to other systems and pull data and send data. So Application Program Interface. So Tarun needs to extract data from a warehouse that has an application program interface. To accomplish this, Tarun uses the curl command to reach out to the data warehouse and pull the information he wants from the system. The command looks something like this. So the command is curl -v-d, and they're specifying a token. So the token is like a shared password that you create. Data that you want -d. So You're sending the content equals record. The other data that you want is you want the format to be in CSV, and the other type, other data that you want is you want the type to be in flat format. And then you give the server address of where you're trying to connect to, and then you output the results of the curl command to a file. So we told the command curl command we wanted a CSV file, and so we save it as all data.csv. Like I said, the token gives the command, basically not the person, but gives the command itself the permission for one computer to connect to the data he wants to extract.